Hello guys, my name is Dr. Varun and here I am back with 30 days, 30 most important topic for NEET 2025 biology.
Chalo, let's complete it.
So in today's class, we're gonna be covering two different topics from two different chapters which are equally important. What are they? Number one is the cardiac cycle. Number two is the functions of the tubules. Starting with the cardiac cycle. So let's just talk about from the perspective what kind of questions could be asked from this topic. So the first topic is cardiac cycle. Now first of all, remember that one cardiac cycle is of 0.8 seconds. So one cardiac cycle is equals to 0.8 seconds. So in a whole of this, like your minute, there will be total 72 such cycles will occur. Okay. So in 1 minute, we will have 70 on an average. I'm telling you, on an average, 72 cycles will occur. Now in this 0.8 second, for 0.4 second, whole of the heart is resting. Okay, whereas for the rest 0.4 second, different part of the hearts are working. I assume that you know about the what is atria, what is the ventricle. So we will go directly into it. So this 0.8 will be divided into two time zones. One is 0.4, one is the 0.4. So this 0.4, this would be what? It will be where the relaxed state will be there. For the relaxation, we use the word diastole. Whereas for 0.4 second, there will be contractions. Means when the contraction word is there, contraction occurring, we call it systole. This thing you have to remember. Within this 0.4 second, it is also divided into 0.1 second, 0.3 seconds. Out of this 0.4, 0.1 second, there will be atrial contractions or means atrial systole that will occur. Rest 0.3 second of it, atria will be resting. So means 0.3 second, atria resting or relaxing. Second point over here only we have to understood that if this is the case, then 0.1 second, the rest of the thing is what? Ventricle of the hearts. So over here 0.1 second of this 0.4, okay, of this, okay, in this the ventricles are relaxing over here, whereas 0.3 second atrial relaxing means the other part would be contracting. So here what will happen? The ventricular contracts. So the major question occurs that if this is the whole thing, then can we say that out of it, the ventricle is working in 0.3 second, ventricle is working for 0.3 seconds and resting for the 0.5 seconds, right? Correct? Because the left out time they will be resting. Of course, there's a part 0.4 second where whole of the heart is working plus ventricle is taking little longer. Atria working point 0.1 second only, rest 0.7 second atria is relaxing. So we can show that in the help of a circular graph kind of a thing. Okay, pie graph kind of a thing. So we will just gonna see those things. So what I said till now, over here I am writing that total atrial contraction in one cardiac cycle is 0.5 second. So total atrial relaxation means diastole. Atrial diastole would be 0.7 seconds. Total ventricular contraction is 0.3 seconds. Total ventricular relaxation would be 0.5 seconds. Let's just make this thing into a pie graph. So let's see that. So this is a circle. Okay, this circle would be, there will be two circles. Okay, The inside circle is representing what? It is representing the atria, and the outside circle is representing the ventricle. So this is what? This inner one is representing atria. Okay, I will make it with a different circle color itself. So this. Wait. This. Okay. This red color one is atria. This white color one is the ventricle. Okay. Now this is representing one cardiac cycle. So we will divide it. Okay, if you see that this divide means that it is starting from, this is the 0 seconds. From here, half of the cycle, 0.4 second would be available. So rest of the time would be what? It will be this time if I am writing it down. If I am writing this whole time, this much time is what? This much time is your, where the diastole is taking place. Okay, so till here to here, I will make it with a thicker one. Till here to here, what is happening? This is joint diastole. Give me a minute. And now if we see that we're dividing it further, the rest of this portion would be what? Where the systole is occurring. Comprises of both atrial systole and ventricular systole. Systole means contractions. Okay, so here let's just divide this whole thing into further parts. This is, now what happened? 0.2 second. This is 0.6 seconds. Further dividing it, 0.1 second, 0.5 seconds. Further dividing it, okay, wait. That is 0.3 seconds, 0.7 seconds, and this is completing 0.8 seconds. Okay, now in this, let's just try to understand what is happening. This part is the only part, this is atria. This is the only part of the atria when the contraction is occurring. So can we write that this portion is where the atrial contraction occurring? Okay. Rest, we told you that once the atria will contract, after that ventricle used to contract. So what will be the next thing? This thing, these three parts. This, sorry, we have to see the ventricle, the white color. This part, 0.1 second, 0.1 second, and 0.1 second. So here, once the atrial contraction is over, from there the ventricle contraction will occur. So this yellow color one is what? Ventricular contractions or ventricular systole. We will write it contraction or systole, whatever you want to write it. This is occurring. Then the major question, what is the other part that is being left? Other part means what? This area is showing what? It is showing the atrial diastole. This portion is showing what? Which is not being colored by anything in the ventricle. Ventricular diastole. Okay, so I hope that this graph is understood. So this whole part from here to here, it is representing what? It is representing atrial relaxation or atrial diastole. Okay, this is systole. Systole. Moving on, this area, making it with this one. So what's the area? That from here to here, this part is what? When the ventricles are what? Ventricular relaxation or diastole. So they can just make you this circle and they will say that what is representing what, which seconds to which second representing what. So this is the cardiac cycle that you have to remember. Further, if they want to make it more informative kind of a question, so let's just see that what can happen. They said that here in the initial, this point, what happened, which node work. So over here, this thing is what? SAN node stimulated. This area, which node stimulated? AV nodes plus Purkinje fibers stimulated. So this thing is there about the cardiac cycle. I hope you would have understand the little bit of cardiac cycle. More to it, there is what the sounds that would be produced over here. So once, what will happen? Once the atria contract and after that ventricular will contract. In between the atria will open up and every blood will be flowed down, and once the whole of the ventricles are covered up, the walls will go like this. As the walls go like this, it will produce first sound, and that is known as lub sound. This lub sound that is being produced, it being produced by the closure of atrioventricular walls. There will be what? Atrial walls, sorry, there will be mitral walls and there will be the tricuspid walls. Okay, moving on, there will be what? There will be dub sound. That will occur when the blood will be pumped from the ventricle into the walls, into the your arteries and capillaries. Okay, arteries. So that will be what? That will be closure of semilunar walls. That is all about the cardiac cycle. Okay. Now let's just see that the functioning of the tubules, how the tubules are working of the nephron. So it is one of the requested topics, so we are compiling it in this topic only. Okay, so you know that the first step would be what? Ultrafiltration. During ultrafiltration, we say that most of the things just go inside except the plasma protein. So just imagine that everything, when it is coming out into the Bowman's capsule, where it will go? It will go to the PCT. Now in PCT, okay, what is happening? That you know that a lot of water is there. So that water, like, because we know that 99% will be there into it. If we do not let most of the water to be reabsorbed, what will happen? Around 180 liter of urine will form. No one excrete 180 liters. We excrete only what? 1 to 1.5 liters in a day. Means 99% of the filtrate which has been formed by the Bowman's capsule or in the Bowman's capsule is actually being reabsorbed. So reabsorption, and during the time of sometimes when this ultrafiltration is there, still some of the people left. Okay, means some of the toxic substances still present into your capillaries. We don't want that, so it has to be secreted back into the things. So there will be reabsorption of the water and the important substances from this tubule into the blood vessels, and from blood vessels, if there is any waste substance present, we have to throw it back inside it. So over here, there will be what? Reabsorption. If something is being reabsorbed, it will be reabsorbed into what? Into your capillaries. So we know that here the efferent arteriole is there, which is coming out from what? From this capillary area, that is glomerulus. Part of what? Part of afferent arteriole. This efferent arteriole, it forms what? It moves around this whole thing. Okay, this whole structure, it's moving. It has branches over here also. Branches is going here also. Everywhere branches are there. Okay, branches are present like this. Okay, branches is even covering like this, so that the things can go and up, which we are not showing it over here. Okay, so this thing is over here. This we will make it like this. Okay, so these branches are everywhere. Now first thing would be what? There will be tubular secretions, tubular reabsorption. So if you see the PCT, maximum absorption is taking place here, because they are made up of what? They are made up of brush bordered cuboidal epithelium. So if the brush border cuboidal epithelium is present, it will what? It will increase the surface area for the reabsorption. So maximum reabsorption will take place over here. So if the reabsorption is being taking place, means most of the thing is being reabsorbed by these cells and will be thrown into what? Into the blood capillaries, because blood only required what? Like it will take the good and beneficial things like water and all. So what things will be reabsorbed? So this sign in your book NCRT, maybe in your book, it will be made something like this. So there are certain signs from here to outside. This sign is showing what? That something is being reabsorbed. These things are reabsorbed. So what are the good things? We have water. So water reabsorption will occur. Along with water, we have what? We have sodium chloride also in our body, which is very needed because we take it from our diet. Sodium chloride is very important. That if any sodium chloride went there, it should go. Then there should be bicarbonate. Bicarbonate, you might know that they act like buffer of the maintain the pH balance. So bicarbonate is also important. It will go. The next thing would be what? Nutrients. For example, your glucose and all those things. So glucose and nutrients, whichever is important, they will also go back. Along with that, if needed, K positive, but normally we don't take it in the new NCRT. I think it's not given. If it's given, then you take it or write it. So these things would be taken up, okay, reabsorbed into it. But simultaneously, when this thing is taking place, this positive charge, negative charge going here, it has to be balanced out. Because if you are taking something positive, the negative or accordingly opposite thing should come out over here. So for that thing to take place, simultaneously, if certain toxic substance is present in this area, like the blood vessel which is flowing over here, this blood is coming up, not everything will be done, so it will also throw something, and that will call it tubular secretion. We are secreting something into the tubule, and for that I am using a different color altogether. That is like this. So what is happening? Certain things is being secreted into it. Okay, so this tubular secretions which is being secreted into it by this capillaries in the PCT area, this is called, this is what? This is your tubular secretion. This is to maintain the ionic balance during the type of tubular reabsorption. So what all the things would be secreted from the blood into it? Only the waste substance that has to be thrown out with the urine. So what would be the waste substance? There would be H positive, which will cause acidity. We don't want the acidity to be in our body, so we will throw them up. Along with that, we will throw even the ammonia if it is present. So ammonia, if it is left out, it will be thrown into it. Now what will happen? This whole thing will go towards the next destination. That is what? Your thick segment of the loop of Henle. So this whole thing is what? Your loop of Henle, thick segment of loop of Henle, thin segment of loop of Henle. Now this loop of Henle, this descending portion of the loop of Henle, it is only permeable to water. So water reabsorption will occur. So here what will happen? That water reabsorption will occur over here. So water reabsorption will occur. Rest, it is impermeable to all the electrolytes. Impermeable to electrolytes means nothing else will be reabsorbed. And simultaneously, when it goes up, like from here, the flow will go up. But if you see over here, if water is being reabsorbed, already maximum water has been reabsorbed at the PCT, 70% of it. But if further water is being reabsorbed, what is happening? It is making that water content becoming low, and the urea which is present in the urine, it will becomes higher in amount. If the urea, H positive, anything, these are what? Solute. So solute will be increasing, means the thing will become more concentrated. So by this time it reached over here, the urine is concentrated. Okay, so means its osmolarity increased. Okay, moving on to the next one. Over here, nothing will be secreted into it. Okay, so next come, as it reaches to the upper limb, means which will be going like the blood, the urine will go from here to here. Then what will happen? This area is is permeable to electrolytes. So which electrolytes will be absorbed over here? Then in this blood vessels, there will be absorption of NaCl and NaCl will be reabsorbed, but not water. Okay, so water, no, this is very important. So now just think about what is happening, that NaCl is going out, means NaCl is good for us because we need it. So means what is left? H positive, ammonia and urea. So what will happen? H positive, urea and ammonia is present. Okay, so this thing will only be present into your filtrate which is present. So means it is highly concentrated urine, but as it is keep on going up, this concentration, more things will be added over here. So in the thin segment from this outer area, this dot area which you are seeing, that is what interstitium, urea is present for maintaining the osmolarity. So what will happen? The urea will go inside. As it go inside, its level will keep on increasing. And urea concentration we want to increase. As it's keep on going out, over here in the DCT, no reabsorption occurs. Okay, if the secretion has to be done, then the secretion from this is still present. What secretions would occur? Secretions would be of H positive, ammonia will occur, even the K positive will occur if it is present there. Okay, but nothing else will be occurs in the normal condition. But if there is conditional reabsorption condition present, conditional reabsorption means when your body volume is reduced, and if a system, regulation system is working, then it will do what? Aldosterone will do what? It will increase the reabsorption. So conditional reabsorption will occur from the DCT of what substances? The useful substances like NaCl, like water if it is there, like bicarbonate ion. So that if your body is in the low volume condition, then this will occur. So this is an important thing. Usually it won't occur. Okay. Then if you go to this area into the collecting tubule, this is the collecting tubule. In the collecting tubule area, there will be what? Urea coming out from here into the interstitium to keep the osmolarities maintained for the counter current mechanism. This urea, small amount, keep on going back also, okay, into the tubules from this area. Okay, along with that, there will be secretion by this of what? There will be H positive and K positive secretions that keep on happening inside it for maintenance of pH ion balance and for the maintenance of the electrolytes balance also. Okay, so which is same ionic balance. Okay, that's all about it. I hope you are able to understand it. It's very easy to remember. Just go through it, and if not, then let me know in the comment section. I will give another way of remembering this thing on my WhatsApp channel, that is Biology Simplified English. Thank you.